Hello and welcome to another episode of Ken's Training. Today's training, what we're doing is we are eddy current testing the tubes that are in this chiller right behind me. There's a condensing section and an evaporator section. So let me go over the chiller itself. So it's a shell and tube chiller. This here that I've got my hand on, this is the condenser. There's no insulation around this shell. The evaporator, which is right over here, has insulation on it, keeping your water chilled. Also, you see your piping. You see your piping is insulated as well, maintaining that chilled loop. Because you don't want to lose any heat out of it. You don't want that water to get warm at all or absorb heat. So you keep it insulated. The condensing section on the opposite hand, we don't mind rejecting some heat so that we don't insulate these pipes. Now this particular is a high-speed centrifugal. So this here is the centrifugal compressor. All right, so here's an explanation of the refrigerant flow in the chiller. What happens is the refrigerant comes out of the compressor and it goes down into the condenser. The chilled water, the condensing water, which is in the tubes of the condenser, will allow the refrigerant to condense from a vapor to a liquid, which is collected here at the bottom. Then it goes through a metering device, where at that point enters into the evaporator section, where the liquid refrigerant will boil off due to the water passing through it, the chilled water. The chilled water will give up its heat to the refrigerant, boiling off the refrigerant, turning it back into a vapor, where it travels to the inlet side of the impellers on this large compressor right here. Here's the motor. This is a coupling in between, which is driving the impeller. There's a gearbox over here which operates a set of mains to allow the flow of refrigerant to adjust the load of the refrigerant. So that's how the chiller kind of operates. So these are shell and tubes heat exchangers. So you've got tubes and it's just surrounded by a shell. Inside the tubes in this one here is condensing water. And you can build up some type of calcium, magnesium deposits and things of this nature can be built up on the tubes. You want to keep your tubes clean so you have water treatment that goes on to make sure you've got the right chemicals in there. And then due to the age, we're concerned about how long these tubes are going to last. This particular chiller, which is run an R11 refrigerant, is a little over 26 years of age. So we're performing an eddy current test here to see how the tubes are doing with 26 years of age. You know, how many more years can we get out of this, out of these tubes and out of this chiller? And what is the life expectancy of the chiller? Some people say life expectancy is 25 years, so we're already at that life expectancy. But you can push that out with good maintenance and the repairs and so forth. We have, not on this chiller, but the chiller next to it, we have a tube sheet repair, where you see that blue coating on this condensing tube sheet. Well, we've got some pitting going on in the chiller next to it, so we have to have an epoxy coating put on there, which is going to bring that back out to a natural thickness, extending the life of that tube sheet, therefore extending the life of that chiller. So these are some things that we're doing to take place, part of the maintenance, repairs and maintenance, to extend out the life expectancy of the chillers. So that's it for now.
I snapped a lot on each chiller.
Alright, we're doing eddy current testing here on this chiller. There's the machine, the eddy current machine right down there on the floor. And you can see the readings that are being displayed there for the technician to see. Here he is taking the eddy current testing rod, putting it down through the tube sheet and into the tubes through the entire length of the chiller. He's got it marked off so he knows exactly how much distance he needs to go in through the chiller. And then he's methodically going one tube at a time. You'll see right there how he's doing that. And then that's the sensor head that you see at the very end. But it's a pretty fast process once he gets his machine set up and he is at that point running the eddy current test. So this is the evaporator section that he's on now. You can tell that it's the evaporator section because of the insulation surrounding the shell and tubes. The condensing section doesn't have that insulation. The flat section there is the tube sheet, and then he's going in through the tubes. Alright, so here he is doing the condenser tube, and everything's going along nice and smoothly. You can see the fairly decent speed that you can go at once you've got your machine set up and you're just going from one tube to the next. There you can see it popping out of one tube right into the next. Out of that tube and into the next. So it's like 30 seconds per tube. It actually goes quite quickly. Here is your machine, and it is recording, measuring the wall thickness and what's going on with the tube. So he can determine if there's a thinning situation going on, if there is some type of a wear going on at the tube sheets. This particular condenser happens to have two tube sheets in between, so it's two supports in between. So it's got the tube sheets, one at this end of the shell, one at the other end of the shell, and then two support brackets that it has to go through in the chiller itself. So anyways, this is eddy current testing for the machine. And he's looking at that dot to determine the thickness of the tube, and he can determine the thousandths of an inch of how thick the tube is. And also, as he goes through the tube supports, he can see the pattern that is being displayed on his display there. This particular machine that does the eddy current testing is not exactly inexpensive. This is about $18,000 for one of these in order to do this eddy current testing, which is used to determine the life expectancy of the tubes and what's happening with the tubes with your chiller. So that's pretty much what's happening here. Okay, one small correction on my part. This condenser, as well as the evaporator, actually has three supports in between. So it has the two end sheets or tube sheets, and then three supports in between. So there's like 5 points of contact to get all together for each of the condensing tubes as well as the evaporator tubes.